Hey there, my name's Daniel Rothermel. Thank you for checking out my presentation, Pool Push Purify, Clean Water in Any Season. I'm an amateur outdoorsman. Here's me out on the Appalachian Trail trying to get drinking water from a spring. I'll tell you what, it can be a struggle to get fresh drinking water out there when it gets so cold. In warm conditions, it's already tough, but add some snow and freezing wind to that equation, and you might find yourself struggling to keep it together as you huddle down by a mountain stream, watching water slowly drip through your water filter. Cold hands, a lack of visibility into the filter, and incomplete systems are just some of the issues. I'm going to lead you through my thought process, from defining this problem, to refining the opportunities for improvement, to developing a comprehensive method for tackling these issues head on. But why does this even matter? Well, as most of you watching probably know, humans need water to keep running. And in the winter, it's even harder to remember to stay hydrated. There are a lot of good reasons to stay watered up while out on the trail, including nutrient delivery to your cells, body temperature regulation, and even better sleep. So I want to develop a water treatment method that isn't impacted by the cold, because it will be an excellent option for those camping in the shoulder season, which is defined as late fall through early spring. In order to understand what I'm talking about when I say water treatment, we're going to need to define two important terms: filtration and purification. Environmental testing in research laboratories in Massachusetts explains these terms a lot better than I can in my own words, so I'm just going to tell you what they have to say about them. Quote, water filtration uses either biological processes, chemicals, or a physical barrier to remove contaminants from the water. This improves the taste, color, and purity of the water. Water filtration focuses on impurities such as bacteria or larger particles. Unfortunately, filtration methods don't always remove other contaminants such as chemicals or viruses that may be present in the water. Water purification works to further purify water from contaminants that filtration methods can't address. It removes the chemicals, viruses, and biological contaminants that filters don't, and it uses a chemical process rather than a typical barrier or boiling methods used for water filtration. Water purification removes the minerals in water also, which filtration doesn't typically do. End quote. There are a good number of reasons why you might find problems with your current systems, including that some systems can freeze over and you can't tell. Boiling water to treat it is costly in time and in gas. Batteries, when not managed well, can die in the cold. And iodine, although it works, it tastes bad and it limits the amount of water that can be treated per trip. So I asked myself, what can be improved about this system? Somebody else was asking themselves the same question. Meet the modern trailblazer, a backpacker who always looks for sturdy and dependable gear to support their adventures. Let's call them Austin. Austin is a self-sufficient backpacker who doesn't like being held back by poor gear. He loves to travel the natural world on foot, and he values environmentally friendly products which integrate into his fast-paced day-to-day. One cold weekend, Austin decided to hit the trail. He equipped his backpack with his trusty hollow fiber filter. After a full day of hiking, he went to the nearby stream to collect some water. As he was collecting water, he got his hands wet because he had to dip them into the stream to fill up the filter. Once he finally got some water collected, he watched it filter out slowly. He felt worried about how easy it was to cross-contaminate things in his system, and also he had trouble knowing how soon he should replace his filter, and he couldn't repair it if he needed. Beyond those issues, Austin was losing small parts and having trouble because he couldn't pre-filter the water first, meaning that his filter would get clogged up much faster and easier. Needless to say, Austin was feeling frustrated with his current water treatment system, so off he went to the nearest REI in search of a new one. As Austin was shopping for a water treatment method, he noticed that some current methods of water treatment are more resilient to the cold than others, and some are more ergonomic. But it's hard to find one that is both at the same time. In fact, nobody is making a completely self-contained water treatment system for colder weather. Well, Austin, I'm here to help. These design guidelines helped me in developing a system that excels at filtering and purifying water in colder weather. They kept me on track so that as I was designing, I would make a system that would allow the trailblazer to be prepared to get outside despite the cold. I needed to, first of all, obviously make it function smoothly in the cold. I needed to also make it lightweight so that Austin could pack it with him on his trips anywhere he wanted to go. I needed it to be durable in case he dropped it or ran into something on the trail. I needed it to keep his hands dry because, especially when it's negative 10 degrees outside, getting water in your hands can be really difficult and really suck. I needed it to be packed away too, so that he could keep it in his bag, ready whenever he needed it. I needed it to be a self-contained system with as few loose parts as possible. And I needed it to be repairable, so that Austin didn't have to buy a whole new system if his broke down. I also needed to show the filter health and show it working, so that Austin was aware of the state of his system. So that means, essentially, I need something that's durable and it's ergonomic. I need it to be filtering and purifying the water. I need to avoid cross-contamination, make it repair friendly, and keep everything streamlined. So where do you even start with all of those goals? I started with some classic brainstorming. Now this might look like a lot, but as I brainstormed with the help of some classmates, we broke down my design guidelines into interesting ideas. From old shoes, to ducks, to nesting dolls, to escalators. All those probably don't sound very related, but they informed the next step of my process, which was coming up with potential concepts. I won't talk about all the concepts that I worked on, but I'll go through a few that helped me get to a final concept. The gravity vest started with the idea that I could maintain warmth in the water system by keeping it close to the user's body. This would involve a dirty water pouch, which would drain into a clean water pouch, a sipping hose, and a vest to hold it all together. Another fun concept is the slinky system, which keys in on keeping the user's hands dry. The theory here is that if you use the slinky, you could drop a cup into a water source like a bungee jumper and let the slinky bring it back to you, where you then invert the whole system and filter the water clean. I explored more methods of water collection with the ketchup collection system. If you've ever looked close at a ketchup bottle, there's a silicone slit valve on the inside that keeps your condiments safe until you're ready to use them. And then once you squeeze the bottle, you get fresh ketchup, and the valve closes back up on its own. I thought I could use a valve like this not only to distribute water, but also to collect it. And believe it or not, that worked. After working through these concepts and a couple more, I took what I learned and I combined it all into a final concept, which I call Pool, Push, Purify. Let me break down the basic flow of things here. As the concept title implies, the first step is to pool up, collecting water into a primary chamber. Next, you push it back down through a filter. And finally, it ends up in the purification chamber where it gets purified. In order to make this this concept real, I got to prototyping. I began with a simple prototype to see how a silicone slit valve would interact with the housing of an AeroPress Go, which was a big prototyping tool for me during this project. I confirmed that I could get a good amount of vacuum pressure by seeing the air get sucked out of the cup there. This told me that it would work on water too because air and water are both fluids. I like the simplicity of the silicone slit valve, but I wanted to explore a more robust option to see how durable I could make this system. So I came up with a concept for a bidirectional valve, which would essentially allow the user to collect, hold, and then distribute water as desired, all while keeping their hands dry. I began prototyping this valve with the help of my trusty AeroPress, and while I got a good upwards flow, the water retention wasn't working as I hoped. So I developed a new version. And this time I took the outlet holes off the top, thinking that this would keep the water from flowing back out through the bottom, and instead allow the water to flow around the outside of the top piece there. Although it worked, it didn't work quite enough, so I tried out some rough methods of sealing it up and eventually even developed a version that housed a silicone O-ring on the inside. Unfortunately, this still dripped a little, and I was running out of time to keep testing, so I had to shift the design. And so I shifted and tried using fine stainless steel mesh as a semi-permeable membrane, and that actually worked. It would allow water to be collected, retained, and distributed as desired. Now that I had a working bidirectional valve, I had more aspects of the design to tackle, starting with the ergonomics. I sketched handles, and I sketched more handles. I went from sketches to sketch models, which then led to 3D models. This one was pretty comfortable in the hand, but I realized after seeing it in person that it was just too big to fit into a streamlined system, so I got back to the drawing board. Designing a handle that would be big enough to allow at least 3 gloved fingers in for leverage, but not to be any bigger was a challenge. But with careful measuring, I landed on a winning design. My next challenge was how to incorporate this design into the overall system, and I considered all kinds of ideas, from sliding it into place, twisting it on, or even using 4-sided cantilever snap fits. My favorite idea, however, was to keep a handle attached to the rest of the system, implementing a pivot hinge, which means that the user could keep the handle on the system at all times instead of, like I said earlier, having a loose part. I 3D printed a version of this design, and after working out a few kinks, I got to a preferred design that would fit perfectly with everything else. I still needed to put all of the pieces together. I was considering what to do for the purification element of the design, and I decided that UVC LED light would be a reasonable and lightweight option for colder weather. In order to use UV purification, I needed to consider the management of the batteries that it would take to run. Throughout the whole time I was prototyping and testing, I kept in mind different options for maintaining a simple overall user experience. I also kept working on what possible methods I could use to discourage cross-contamination, which led to a double-sided spout design. As the weeks passed by, the vision became clearer and clearer, and I started to be able to stylize this system while considering all of its moving parts. And finally, I'm proud to introduce the Stream Sipper. This is an all-in-one water treatment system that allows the user to dependably collect and purify water in colder weather, all while keeping their hands and or gloves dry. It benefits from a durable construction of stainless steel, Triton Renew, silicone, and wheat straw plastic. Let's talk about what it looks like to use the Stream Sipper. The handle has a soft silicone grip, which provides a strong clutch for pulling water in from a water source. The top chamber goes straight into the water source, equipped with that built-in stainless steel pre-mesh filter that also doubles as a bidirectional valve. All it takes is a pull upwards to fill it up. Once the water is collected, it's pushed back through a carbon block filter, which is a more durable option in colder weather since it doesn't crack as easily if it gets frozen. If your filter does get compromised, it's very easy to replace by simply pulling the holder apart at the snap fits there and putting in a new one. Once the water has been filtered, it flows through the first side of the spout, and from there, it enters into the purification chamber. The UV light purification is initiated by pressing the purification button, which lights up to indicate that it started. As the water is being treated, the indicator light turns off to save energy. Reaching the required 60 seconds, the indicator light flashes 3 times to show the user that the water has been purified. Now that they have purified water, they can sip straight from the other side of the spout or pour the water out into their bottle. If they would like, they can also remove the battery when it's not in use to keep it warm in their jacket or to give it a charge with the USB-C charging port. Now that you can see how the whole system works, I want to touch on the repairability of internal components. Although the silicone plunger probably won't wear out anytime soon, it can be taken off either for cleaning or replacement. The mesh pre-filter can also be replaced as needed so that the user doesn't have to buy an entire new system. As I mentioned earlier, the carbon block filter is also accessible for easy replacement. Finally, the UVC LED can be replaced as needed, and the battery pack can be serviced as needed too. So you remember Austin? Let's see how he's doing with the stream sipper now. Since he got the stream sipper, it's been much easier to keep his hands dry without sacrificing clean water. He also worries less about cross-contamination because of the innovative spout design. It's much faster to gather water with the sipper, and the pre-filter keeps the carbon block working faster for longer. Finally, Austin can easily repair his parts himself if he ever needs to. Looking to the future for this project, I would love to see more functional prototyping, which could lead to scaling production up. Beyond there, I see this as a useful product in other industries than backpacking, including winter sports and wilderness jobs. I just want to say thank you to everyone at the ICC who helped me along this journey, including Gabe Pyle, Jacob Tesmer, Tom Balliot, Jim Stevenson, John Losco, Sarah Lacey, and all my fellow students, and anybody else I might have forgotten. Also, thank you to everyone who's had my back as I've worked to become a better designer step by little step. And thank you to you for watching this presentation. I really appreciate you taking the time to take it in. And if you have any questions or you'd just like to connect, you can always message me on LinkedIn, or feel free to check out my portfolio for other projects at danielrothermeldesigns.myportfolio.com. Thank you.